Alright, so here's our next lesson, and it is on generating equivalent expressions. Keyword here is equivalent. So previously we worked on just creating expressions. Now we are going to create two expressions that are equal to one another. Alright, so our two objectives, I will be able to create equivalent expressions and identify equivalent expressions. Okay, so first we need to know each of our pieces. So inside of an expression we have what are called terms. Terms are numbers, variables, products, or quotients in an expression. Okay, a term is not a sum or a difference. Alright, so each of these pieces here are considered terms. And the next one, coefficients. Coefficients are numbers that multiply a variable. So any of the numbers in front of a variable that are connected using multiplication. So in this case, 4, 2, and 3 would be coefficients. Like terms. Like terms are terms whose variables and their exponents are the same. Alright, so here, even though I have 4x and 14x, they're not the same because here the x is squared and here it's just regular x. Alright, so what I like to do when I'm looking for like terms, you can use like this example did where they circled like terms then boxed. If I have my different colors, I really like to use different colors. So using my highlighter and saying, okay, these two are the same, and then xy and xy, so those are the same. Notice the coefficient doesn't have to be the same. It's the variables and their exponents or their patterns, those have to be the same. Alright, so the next thing we're going to talk about are the different properties. So in the past, you've probably worked with a couple of these before, and we're going to expand on those a little bit. So we have the commutative property, the associative property, the identity properties, there's two of these, and the distributive property. Each of these, so right here, these two only work for multiplication and division. And multiplication and addition. And we'll talk a little bit about why. And then the identity property, there's two specific numbers that will work. And the distributive property is its own situation, which we'll get into in a moment. Alright, so first you have the commutative property. Again, it only works for addition and multiplication, so I'm going to split it here and have an addition example and a multiplication example. Okay, and it allows you to move or commute, hence commutative, your numbers without changing the product or sum. So for example, if I have 5 plus 7, I can use the commutative property and move those numbers around to say 7 plus 5. So now here's an expression, and here's an expression, and they are both equivalent to one another. Because if I evaluate them, I get 12, and I get 12, making this statement true. The same thing works for multiplication. If I have 5 times 7, I can use the commutative property and say that 7 times 5 is also the same thing. It's equivalent. So again, one expression, two expressions. 5 times 7 gets me 35. 7 times 5 gets me 35 as well, making this true. Now notice I said it doesn't work with addition or it only works with addition and multiplication. It doesn't work with subtraction or division. Real quick, just to show you why. So if I did 3 minus 1, that would give me 2. But if I did 1 minus 3, that would give me negative 2. And these two things are not equal, so that will not work. Okay, and the same thing here. If I did 10 divided by 5, that would give me 2, but if I did 5 divided by 10, that would give me half. Again, those two things are not equal, so it doesn't work. It only works for addition and multiplication. Alright, the associative property. Again, it only works with multiplication and addition. And it allows you to regroup or reassociate. Okay, so Think about the people that you associate with. It's your group of friends. So the associative property allows you to regroup your numbers without changing the product or sum. So, again, I'm going to do an addition example and a multiplication example. And now it has to be all addition or all multiplication. It can't be a mixture. So here, I'm just going to do 1 plus 2 plus 3, and first I'm going to group the 1 and the 2. Now, if I were to work this out, I know this would become 3 plus 3, which would give me 6. Regrouping tells me that I can do 1 plus 2 plus 3, but now I can group the 2 and the 3, which would give me 5, which would give me 6, making this a true statement. Here I group the 1 and the 2, here I group the 2 and the 3. Again, these are two different expressions that are equivalent. So even though they're grouped differently, so they're in the same order, but they're grouped differently this time. Multiplication would be the same thing, so I'm going to do 1 times 2 times 3, and I'm going to group the 1 and the 2. And I would get 2 times 3, which would give me 6. And then here, that would be the same thing as grouping the 2 and the 3. And then that would be 1 times 6, which would give me 6. All of those are equivalent, so this is true. Again, here's one expression, here's another. Changing the parentheses makes the expression different. All right, so right here I wrote two different expressions, but they give me the same answer, so they are equivalent. All right, the identity property of 0. It allows you to add or subtract from a number without changing the value of the number. Okay, so it keeps its identity. That number gets to stay the same. So for example, if I do 5 plus 0, it stays as 5. If I do 5 minus 0, it stays as 5. Now, the thing is, with subtraction, I have to take it away from a number. Okay, it has to be my second number. It cannot be my first number. So typically when we talk about the identity property, we really just focus on addition, but it is true for subtraction. Okay, so here I could say 5 is equivalent to 5 plus 0. And that's two different expressions. Now I have the identity property of 1, which allows me to multiply or divide a number without changing the value of the number. So again, keeping the identity. So here, I can do 4 times 1, and that will give me 4. Or I can do 4 divided by 1, which gives me 4. I cannot start with the 1. It cannot be the dividend. It can only be the divisor, because this would give me 1/4. This is not going to work. This is false. Both of these are true. All right. Now, the distributive property. This is really the focus of this lesson. It allows me to multiply the sum of 2 or more addends by a number and get the same result as I would multiplying each addend individually by the number, then adding the products. So, that's a lot to take in. So let's take a look at it this way. So if I had a rectangle that was 2 by 3, and I had another one that was 2 by 4, and I wanted to know the area of those two rectangles together, what I would usually do is 2 times 3 plus 2 times 4, which should give me 6 plus 8, which gives me 14. Now let's imagine that we put those two pictures together. So I have, since they're both the same height, I can do 2 by 3, and then I can also do another 4. So now I'm adding the 3 and the 4 first, and then I'm multiplying that by that height of 2. Okay, because here, this is one large rectangle, and the only reason I can do this is because of the fact that both of these have the same height. Okay, so here I have, and actually I should say they both have the same width. All right, so here I can combine these and say that I would do 2 times 7. So here this would be 2 times 7, which would give me 14. both of these gave me the same answer. Okay, so I want you to really picture the visual here. So the fact that you have two areas and you're adding them together, and then here you're taking them to putting them together and then finding the area of the overall rectangle. We'll work with this some more. This is just your first example. All right, so we're going to rewrite the expression and tell what property we use to do so. So in this case, I have parentheses, which means I'm grouping. So I could change this and have A be all by itself, and then group B and C, because this is all multiplication, because it's all glued together by parentheses and variables. Since this was a grouping one, this was the associative property. Now here, I have a common of y and a common of y, and I'm adding those two things. So what I can do is I can take these y's and put them outside by themselves. So again, it's like saying 3 and then saying, okay, well now I also have 4, but both of them have that same height of y. So instead of doing y times 3 and y times 4, I can take it and say y times 3 plus 4. Or I can even take it one step further and say y times 7. Again, this is the distributive property. Here, I don't have anything to group. I don't have a commonality, so I can just change the order. I can move them around. So this would be 7 times 6. There we go, which would be the commutative property. And here, I'm adding a 0. So that tells me that that would just be 7. It allows it to keep its identity. So this would be the identity property of 0. And then here I'm multiplying by 1, which tells me 5 gets to keep its identity. So it's the identity property of 1. Now, 1 only works with multiplication and 0 only works with addition. Remember that. You can't interchange those. All right, so we're going to take a look and see if these expressions are equivalent and then tell what properties we use to work them out. Well, here I notice that I have these numbers grouped together, but with subtraction. So what that tells me, and then I'm multiplying this on the outside. So what that tells me is that I can distribute the 3 to both of these numbers using multiplication to see what I get. Okay, now typically what we've been doing is we've been going the opposite direction. Now what we're going to do is we've been kind of taking back the distribution. Now we're actually going to distribute it. So we have 3 times x, okay, because we distribute the 3 and the x, minus 3 times 2. Okay, and we're trying to see if it equals the 3x minus 6. Well, 3x would stay the same. 3 times 2 would give us 6. So here we can say that yes, they are equivalent. And here we use the distributive property, where we distributed the 3 to the numbers inside the parentheses. All right, now we're going to look at 2 plus x and half times x plus 4. So in this case, we're going to leave this one alone because the only property we could use on it is the commutative, and that won't help us with breaking these parentheses. So now I'm going to take 1 half times x plus 4, and I'm going to distribute it because remember, a number connected by parentheses means multiplication. So I have half times x And I have half times 4, so I have 1/2 times x plus 1/2 times 4. 1/2 x would stay the same, plus 1/2 times 4 would give me 2. Now notice my x is back here, so I need to make that be in the same order. Since it's addition, I can use the commutative property to put the 2 first, plus the 1/2 times the x. And notice this is not equal to 2 plus x. So no, they are not equivalent. And to figure that out, I use the distributive property. And then I also use the commutative property. To make sure that they were in the same order, so that x was last on both of them. Okay, honestly, you guys, it just takes a lot of practice to use the distributive property and all the other properties. The more you practice it and are willing to make mistakes and learn from them, the better off you're going to do. So what I want you to do is I want you to go through, determine if they are equivalent or not, and then tell me what properties you use to work out the problem. And when we come back, we'll check your answers. All right, so here we could have done this one of two ways. We could have looked at 6 and 8 and decided to pull out 2, or you could have distributed the 2 to the 3x into the 5. I'm going to show you both ways, because both ways will get you the same answer. So here, both 6 and 8 are divisible by 2. So then this becomes 6 divided by 2 is 3x. 8 divided by 2 is 4. And I can see that that is not equal to 2 times 3x minus 5. And I still use the distributive property to figure that out. Or I could have done it the other way. I could have left this as 6x minus 8. And I could have distributed the 2 to the 3x and to the 5. So 6x minus 8, is it equal to 2 times 3 is 6, 2 times 5 is 10. Okay, and I can see that these are not equal, so they are not equivalent, and it was still using the distributive property. Here, I can't do anything with the 5x except for move it around, so that's not going to help me out much. But here, I know that 2 minus 2 is going to give me 0 plus 5x. And I know anything plus 0 stays the same, so these two are equivalent. And I know that using the identity property of 0. Next thing we're going to look at is combining like terms. So the first thing you want to do is go through and find those like terms. So if you have colored pencils, this is where you want to take those out to help you identify those like terms. All right, so here it's x squared and x squared. It's really nice because it's only these two. And all I have to do is I subtract my coefficients. So I subtract 6 and 4 and I get 2. And then I keep my x squareds. Because what this means is I have 6x squareds. It's a lot to draw. 1, 2, 3, 4, 5, 6. Minus, and I'm adding those all together, minus 4x squareds that got added together. So for every 1 that's over here, so 3, 4, I have to take away 1 over here. So I'm left with 2x squared. All right, here I can't combine the 3a and the 5a until I get rid of the parentheses. So I have to use the distributive property first. And I have 3a plus 2 times b is just 2b plus 2 times 5 is 10a. Now I'm going to go through and I'm going to identify my like terms, which is 3a and 10a. And they're being combined using addition. So I have 3a plus 10a, which is 13a. 2b is all by itself, and that's still being added to the 13 and the 3 and the 10a, which we combine to make 13a. Here, let's find those like terms. So I have y and 7y are like terms, and then I have 11x and 7x are like terms. All right, so here, y and 7y are being combined by addition. So rewrite the problem to put your like terms together. So y plus 7y plus 11x, because I can switch these because of the commutative property. The only thing I can't do is move that minus 7x. But now I can combine these because they're like terms, and I get 8 y's, because there's 7 here and 1 here. Together that makes 8, plus I have 11 x's over here, and I'm taking 7 away, which leaves me with 4. All right, so now it's your turn. I want you to identify your like terms and then combine them. It's up to you if you want to. I'm going to go through and I'm going to first show how you break the parentheses here. Then I'll go through and I'll identify the like terms. Then I'll go through and solve each one. So that way you can kind of break it down step by step and check how you're doing. All right, so to break the parentheses here, I have to use the distributive property. That's the only way that I can use like terms and shrink this down. Okay, because what I want you to remember is what I did here was I took and made this expression and I turned it into this. And these two things are equivalent. They're equal to one another because they'll give us the same answer. Okay, so I'm using like terms now to create equivalent expressions. So the 6x squared doesn't change. But now I'm taking the 4 and multiplying it by x squared. So I get 4x squared minus, because that's a minus sign, 4 times 1 is 4. All right, so check and make sure that you broke your parentheses correctly using the distributive property. And then now you can go through and you can check for your like terms on each of the problems, and you can come back and check that when you're ready. So here I have 8y and 3y are like terms. Here 6x squared and 4x squared. Here it's 4a to the 5th and 2a to the 5th. But then it's also 4b and b. And then here I have 8m. It's all by itself, so I actually don't have to put a box around it if I don't want to. Got a little excited there. But I do have 14 and 12. I cannot combine 8m and 4n because those are different variables. All right, now you can go back and you can combine your like terms. Otherwise, you can keep checking your work with me. So here, 8 minus 3 is 5, and then I keep the y. Here, my x squareds they're already together, and they're being combined by addition. So my coefficients of 6 and 4 added together give me 10 x squared. And then I keep my minus 4. I can't get rid of that. Now here, what I can do is I can move things around a little bit, or I can just combine as I move around. So I can move the plus 4b behind the plus b because it's the 2a that's being subtracted, not the 4b. So I can rewrite this as 4a to the 5th minus 2a to the 5th plus b plus 4b. Then I can go ahead and combine. 4 minus 2 is 2, but I keep my a's to the fifth, plus 1b plus 4b gives me 5b. Here, the only thing I can combine are my subtraction of my terms. So 14 minus 12 is 2, so I have 8m plus 2 plus 4n. Again, this becomes a lot more simplistic when you practice it a lot. All right, so here what I did for you is I actually split this up into two different pages for you. So this part is on the first part and this part is on the second page. So you have more space so you can show your work. Take your time. Please, please, please solve them. Show your work. You're going to need so much more space for these problems down here. So be sure to use it. You also have the back page to use as well. And as always, if you have any questions, please be sure to email me or write them down so we can go over them in class.